Zero. When it comes to climate change, there's no bigger goal than zero emissions, and no bigger challenge for the energy sector. Today, CO2 is the #1 contributor to climate change, with 41% of CO2 coming from power. Change isn't happening fast enough, and a growing renewables segment can't solve this alone. By 2040, electricity demand will grow by 50%. Solar and wind are expected to contribute just 28% of electricity. And coal is expected to still contribute 22% of electricity and 70% of the power sector's CO2 emissions. So, how can we move faster? By utilizing more of two energy sources, renewables and gas power. These two energy sources can do more together. By combining electricity from renewables when available with gas power that's there whenever you need it, the world can cut CO2 emissions from power plants up to 80%, starting now, not decades from now. At GE, we're leading the way in the industry today, and we're continuing our focus on innovations for tomorrow. Technology that could lower wind energy costs and give gas power plants a pathway to near zero emissions. GE is proud to work alongside great partners and support strong policy ideas that will move the industry forward. That's how we're making progress, piece by piece, building towards zero.
Hi, I'm Jeff Goldmere, GE's Fuel Guy. And today I want to talk to you about a topic that's on a lot of people's minds in the energy industry. You've heard a lot about hydrogen. You remember it? It sits at the top left of the periodic table. The most abundant element in the universe? Well, here on Earth, it's typically found with other elements. Hydrogen and oxygen form a very familiar substance. We all know it. It's water. And when hydrogen and carbon combine, we get hydrocarbons, which we think of as fuels. Remember me, Fuel Guy? The simplest hydrocarbon is methane. 1 carbon, 4 hydrogens. So the question I get asked all the time is, can hydrogen be used to produce power? The answer is yes. It's happening right now. There are many steel mills, refineries, and petrochemical plants that generate gases containing hydrogen. This excess gas can be burned in a gas turbine to make power. And GE has been providing gas turbines for these industrial power applications for decades. The good news? Displacing a hydrocarbon fuel with hydrogen can lead to reduced CO2 emissions. Yes! But today, we're all focused on the future. With increased interest in renewable energy, hydrogen and its carbon-free status make it a very attractive energy source. And because we can already burn it in gas turbines, we may be able to use some portion of the existing power infrastructure in our hydrogen future. Another piece of good news, since GE has been developing fuel-flexible gas turbine combustion technology for a while now, we understand the benefits and the challenges of using hydrogen as a power generation fuel. For example, hydrogen's volumetric energy density is about 1/3 that of natural gas, or methane. So what does that mean? Let's talk about a real example. Say you need to eat 1,000 calories at lunch. Now you could get those calories from my favorite, a juicy cheeseburger. Or you could have the healthier option and eat lots and lots and lots of salad. What does this mean in practical terms? Again, remember, hydrogen's volumetric energy density is about 1/3 that of natural gas. So we have to flow 3 times as much gas. So we have to adjust the fuel system to accommodate the increased flow. Hydrogen has other chemical properties that set it apart from other fuels. It burns much hotter and is much more reactive. In our state-of-the-art combustion lab, which you can see behind me, we're analyzing existing combustion systems and developing new ones for fuels with hydrogen. And what comes out of the lab? The DLN 2.6e combustion system, which has capability to burn fuel blends up to 50% hydrogen. And we've applied this combustion system to the 7HA and 9HA gas turbines. And remember, it's all part of GE's commitment to exploring and developing a greener energy future. Want to learn more? Visit our hydrogen webpage today. Hi, I'm Jeff Goldmere, GE's Fuel Guy.
And I'm Simon Blakey, the IHS Market Energy Expert.
Today we want to talk about the future of hydrogen and its contribution to a potential future low-carbon society.
Hydrogen is a zero-carbon emission fuel, making it a very attractive source of energy.
Now, what does this mean for the future? There are a few things to consider.
Let's look at physical infrastructure as it relates to hydrogen. How can we make, store, and transport it?
Today, most hydrogen is made by reforming natural gas in a process that requires high-temperature steam. But this process also creates carbon dioxide. An alternative production method is electrolysis. Here, an electric current splits water into hydrogen and oxygen. If the electricity is produced by renewable sources, like wind or solar, the hydrogen can be considered green, completely renewable, without the production of any carbon dioxide.
Now that we can create hydrogen, there are a few ways to store it. You can liquefy it by cooling it down to very low temperatures and then store and transport using cryogenic technology. You can compress hydrogen to store as gas at very high pressure. Or it can be processed to form liquid compounds that are easier to transport, like ammonia.
But what if I wanted enough hydrogen to power a city? Assuming the hydrogen was stored as a cryogenic liquid, the tank volume required to supply enough hydrogen to, let's say, New York City for a single year would be larger than the volume of 10,000 Olympic-sized swimming pools. We probably won't find the space we need for that, so let's consider existing natural gas pipeline networks instead. Pipelines could transport the amount required. Existing pipelines may be able to carry up to 20% by volume hydrogen. But physical and technology changes would need to be made to existing infrastructure to safely deliver 100% hydrogen.
So, moving to a hydrogen society won't happen overnight. It's going to take major shifts in the way we think about economies, infrastructure, and technologies. But it's important that we continue the dialogue around the production, storage, and transport of hydrogen so that we can plan for the future. Today, countries around the world are already developing plans. They're addressing hydrogen infrastructure needs through national policies and pilot projects. And the pilot projects are getting bigger.
GE also recognizes the strong role hydrogen plays in a carbon-neutral future, which is why we continue to develop and improve our technologies to unlock its potential.
Want to learn more about the potential of a hydrogen future?
Visit our hydrogen webpage today.
Hello everyone, my name is Lila. Welcome to PT GE Nusantara Turbine Services Indonesia or PT GENS. Located in Bandung, Indonesia, PT GENS is the GE B&E Fleet Global Center of Excellence specializing in gas turbine repair. PT GENS has more than 25 years experience with more than 120 diverse employees. Now, I propose you to take a tour on the site. Please follow me. The lean methodology concept helps the service center to streamline their process and as a result, increase turnaround time of customer components so we can better meet their needs. All of this happen on just under 5,000 square meters of indoor shop footprint. Coating facility that utilizes robot-driven thermal barrier coating technology to provide the thermal and oxidation protection to metallic substrate against high-temperature gas of engine hot section. Adaptive CNC and conventional machining to enable appropriate machining with the required precision, be it for turbine blades, bearings, or for other components. Turbine blade moment weigh with blade optimization software to determine the optimal arrangement of blade that will minimize the rotor's total unbalanced level. The in-house vacuum heat treatment and brazing facility allows us to treat up to 2-ton capacity to rejuvenate the material structure or braze repair a specific component. robotic surface treatment such as shot pin to ensure that the turbine blade achieves the desirable property, while the cold spray to enhance the sealing property even with a complex geometry. CMM dimensional inspection or FAROAM to provide accurate dimensional inspection for a complex geometry. Non-destructive testing, such as red dye penetrant, to detect the crack or linear indication for all ferrous and non-ferrous material. Fluorescence penetrant inspection has a good sensitivity for such small defects. Metallurgical testing typically use microscopy to provide important information about the structure and mechanical properties of metal and alloy sample, as well as tensile testing machine.
Malaysia's recent economic growth has driven a steady increase in power capacity, answering the rising demand for electricity. With the country's latest development plan to add more renewable power while reducing dependence on coal, gas power remains critical for the country's prosperity. To ensure efficient and reliable power for the country, Southern Power Generation and CTCI partnered with GE to build and maintain the world's first gas power plant powered by GE's 9HA.02 technology at Track 4A in Malaysia. The plant is equipped with GE's latest technology and proven digital solutions. This advanced configuration delivers unmatched combined cycle efficiency and high cyclic capability. GE's H-Class combined cycle plants equipped with HA technology are demonstrating industry-leading reliability customers can depend on. Featuring superior responsiveness and flexibility, it enables plant operators to dispatch power to the grid quickly. GE's HA gas turbine portfolio is the fastest growing fleet in its segment, with more than 120 units ordered by more than 48 customers across 20 countries. For 21 years, GE will provide service solutions across the plant's assets and run its Predix asset performance management software to help improve asset visibility, reliability, and availability. Together with GE's expertise and support on-site, this will ensure the long-term operations and sustained power dispatch to the grid. As a result of the partnership with our customer SPG, the Track 4A power plant is now ready to contribute to long-term energy needs in the country.
Have you ever thought what happens when you flip a switch and the lights come on? How electrons are generated, transmitted, and harnessed to where you are. I'm Ehab Shaban with GE, and I enjoy being part of the beginning and end of this journey. The concept of the electrical grid has evolved substantially over the past few decades to meet the massive growth in energy demand. Grid stability remains, though, the most critical need for grid operators that must aggregate and dispatch the available resources on the network while lowering overall cost and environmental impact. While renewable energy sources exhibit lower operational costs and lesser greenhouse gas emissions, they also introduce challenges when integrated into the electrical grid, such as intermittency, lack of synchronous inertia, frequency and voltage irregularities, and seamlessly integrating with the existing generation mix. Grid firming is utilized to address the imbalance created by the intermittency and low capacity factors introduced by solar, wind, and hydro resources. The GE aeroderivative gas turbines have a track record of addressing those challenges by operating concurrently with both conventional and renewable resources, lowering operational costs and emissions with the highest reliability in the industry. As you see here in the CPV Central site in California, where 8 LMS-100 aeroderivative gas turbines operating along with wind farms, or the LM6000 in the Indigo site in California interconnected with solar and wind, or the Southern California Edison with an LM6000 operating in hybrid mode with a battery energy storage system called the EGT. These are all examples showing how the GE aeroderivative technology has been the right fit in balancing renewables on the grid or supporting specific ancillary services. Here at GE, whether we're helping folks powering small villages in Africa or powering large cities in Asia or the Americas, it all comes down to one thing. Everyone needs reliable, stable, and cost-effective electrical power. The GE aeroderivatives support grid firming to reliably and economically deliver an environmentally friendly solution. We look forward to working with our customers on more projects to support their needs on grid firming and hybrid applications. And we thank you for being part of this journey.
As the adoption of intermittent renewable energy resources grows around the world, the ways traditional gas-fired plants operate are evolving. This is driving many assets to run at less than optimal minimum loads to ensure grid reliability. As the global renewable energy expansion continues, these assets must transform to affordably deliver on today's market needs. GE's LM6000 hybrid electric gas turbine is engineered to flexibly, reliably, and affordably deliver the reserve generations our customers need by integrating a 10-megawatt battery storage system from GE Energy Connections. Upgrading the control system with GE's OpFlex package enhances the flexibility of the turbine while also integrating the operation of the battery and gas turbine controls. This enables immediate response to changing energy dispatch needs and results in fuel saving, lower maintenance costs, and reduced emissions. Here's how. While the gas turbine is not online, the battery can provide reactive voltage support and primary frequency response to the grid. The combined system can also act as a contingency reserve asset with 50 megawatts of power available to instantaneously start ramping up to support emergency grid needs, all without burning fuel or creating greenhouse gas emissions while immediately ready to respond. When it's time for the gas turbine to generate power, the battery can cover the immediate power needs of the grid while the gas turbine ramps to full load. Once online, this system can provide 50 megawatts of flexible capacity or peaking energy and 25 megawatts of high-quality regulation. Our enhanced digital capabilities manage the blended LM6000 hybrid output by intelligently scheduling gas turbine output and storage system output while maintaining state of charge for the battery system at all times. During operation, the storage system handles transient response, reducing thermal stress on the turbine and improving life cycle costs. The LM6000 Hybrid EGT offers superior grid support at a lower cost and with a smaller footprint than traditional resources. Multiple ancillary services can be supplied in one system. Contingency reserves, regulation, voltage support, primary frequency response, all of which increase the utilization of your asset. At the same time, the hybrid helps reduce the demand on expensive peak resources and the need to run turbines at minimum loads to maintain spinning reserves. This lowers overall emissions and fuel use to supply these reserves to the grid, while also lowering the gas turbine's life cycle costs, delivering greater value for the energy provider and consumer. The LM6000 Hybrid EGT draws on industry-leading expertise from multiple GE businesses through the GE Store to provide high quality and power and grid support that delivers value to our customers.